There you go.
We're live.
Cool.
Cool.
All right, this is live.
So who is going to start?
Probably you.
Me? Okay, fine. All right, so I took section A 10 and section B 4, I think. So we'll start with A. Let me just scroll down to it. So this one's pretty long. So section A had two different parts to it. I think they all do in section A, but so it was mostly questions about Ruby. So the first section is the three pillars of Ruby are everything is an object, every operation is a method call, and all programming is metaprogramming. And then I had to define and explain what each of those pillars means. And then part B to that was provide two examples of each. So you guys can tell me if I was stupid and any of this is wrong.
You're stupid and wrong.
Thank you, Alex. All right, so these are my explanations. You can tell me if they make sense. Everything is an object means quite literally what it sounds like. Everything in Ruby from classes, and then in parentheses I just said they're instances of the class basic object, to primitive types. You know what? Going to add like such as, oops, such as.
Do it in color. Change the so you know. Cause like right then we'll have edits to make, so it'll be better.
I'm just going to write add example. But primitive. It'll take too long to go in and edit stuff like that. Okay, so to user-defined types, to primitive types such as integers, to user-defined types are objects. So basically saying, you know, everything in Ruby is an object, numbers, strings, everything's an object. This then explains how every operation is a method call. Since everything is an object, operations are all implemented as method calls on instances of the object. Rather than being part of the language, all operations are actually instance methods of the class of the object they're being called on. This allows for behavior of an operation on a specific type to be directly specified in that class, rather than having issues that may arise from casting when working with incompatible types. This also means that all operations have some return value, even if that return value is nil. Lastly, the code is fully reflective. Lastly, all programming is metaprogramming because Ruby is a fully dynamic language. The code is fully reflective and can modify itself at runtime. All programming is metaprogramming because, as stated before, classes are actually objects. Thus, the code inside of these class objects is constructed at runtime, and it can be edited. So that's a little nicer. Did anybody find anything wrong with that explanation?
Nah.
You like it?
Is she gonna get mad if we like don't make edits, or does it not matter?
No, you know, if it's good, it's good.
Well, like, yeah, if we don't have to, I don't see why. Like,
I
it's.
mean, I wrote something.
We should also be looking over the actual like wording to make sure that it's all like grammatically correct, because she wanted that.
I mean, hopefully, like I fixed a couple things as I was reading it, just because I was like reading it, so I could see things and I cleaned them up. These aren't a big deal. Here, I'll just say proofread edit. So, all right, so part B was giving two examples of those three different pillars. So, one, everything is an object. The example I gave was one.class returns fixnum. So, one is an object of type fixnum, and class is an instance method of fixnum. So, that's just an example of showing, you know, one is an object. That's why you're able to call it class. So, two, fixnum.class returns class. So, one being an integral type, a primitive type, is actually an object, and then fixnum, which we've already established is a class, actually is also an object. So fixnum.class returns class, meaning the class fixnum is an object of type class. So that's just showing how everything is an object, even primitives to classes. Two, every operation is a method call. Pretty much I just showed how things that you would expect to be operators, not methods, are method calls. So 1 plus 1 is syntactic sugar for 1.send the plus operator 1, and then the second example was indexing an array at the 0th position equals 1 is also just syntactic sugar for array.send the bracket operator equals, and then taking the parameters 0 and 1. So it's just showing how it's actually a method call in syntactic sugar. And then all programming is metaprogramming. First example was Attribute accessor my variable, some name, is really just a method call that will create getter and setter methods at runtime for an instance variable with the name my var. So it actually generates code at runtime based on that. It's just a method really. And then 2, adding a method to an existing Ruby class, such as adding a new operator to the array class, because it actually reopens the class at runtime and inserts new code for that new method. So, you know, it's fully reflective and able to inspect and edit itself at runtime. So section 2 was a bunch of different questions. You might have to like actually read these to see if I was correct, but I'm pretty sure these are all good because they're pretty straightforward. But like it was turn a times b plus 5 into the send variety. So a times b plus 5 is actually just a dot send times b dot send plus 5. So you have to evaluate a times b first. So a dot send times b and then dot send plus 5. Num mod 2 is as simple as num dot send the mod operator 2. String 1 equals string 2 is as easy as string 1 dot send the equals operator string 2. And data, like data, if there was an array, bracket n is the same thing as just data dot send bracket n, so that you can tell position. Those are pretty straightforward, easy ones. So the second one, part B of section 2 was regular expressions. So you might need to read them to see that I'm right, but I'm pretty confident in these also. So basically, the first one is checking for valid emails, and the second one is checking for valid web addresses. So for the first one, it's like the first bit, it has to be the start of the string to the end of the string, but the first chunk has to be any character that belongs to the set, including all lowercase letters, A through Z, digits 0 through 9, the underscore character, the period character, or the dash character, and it has to be followed by the @ character. And then that can be followed by any number of characters belonging to A through Z, lowercase a through Z, 0 through 9, the dot character, or the dash character. And then that's followed by the period character and exactly 3 digits from the set A through Z. So basically something at something dot 3 letters. So it can check that things are within the proper generic format. So like my email, meagerl1@binghamton.edu will be a match, or I gave examples also though of things that will be a match but are obviously not real email. So like ab_.cd4@09-.aaa is a match, which is obviously not a real email. So it can confirm that real emails are real, but it can't confirm that a fake email is fake. Also, if you use capital letters in an email, it can't tell that, so that's a limitation of it. The reason I'm telling you this is because it says what are the limitations.
Yeah, I was gonna ask. Okay, I read that.
Yeah, I wasn't wasting your time. The part of the question saying what are the limitations. Also, it can tell that like .com is valid, but it can't tell that .cmo or .aaa are invalid. And also, it can't match like 2-letter domains, so something like .io or .co. It can't match those because it has to be 3 letters, and you can't use capitals anywhere, like I said before. The second one is basically checking for valid web addresses. So from the start of the string to the end of the string, you can optionally have HTTP and then optionally S. So either you have the entire chunk HTTP or HTTPS, or none of the above. Oh, and :// or none of that at all. So basically, you could include HTTP or S, or just start with the web address immediately. Same thing as before. So any combination of the lowercase characters A through Z, digits 0 through 9, the dot character, and the dash character, followed by a period, followed by any 3 letters from the set A to Z. Similar limitations to before. You can't use capital letters when you're trying to look up a website, and you can't use domains that only have 2 letters, like a .io or something like that. It won't work. Also, you can't use, like, I'll add that, can't use www. So you can't use www in a web address or something like that. Okay, so the next question was, what is reflection? So I said reflection is the ability of a program to inspect and modify itself at runtime and then it asked for 2 examples in Ruby of reflection. So I said 2 examples are attribute accessor and the respond to method. Attribute accessor can generate code at runtime for a getter and setter of some instance variable. This is an example of modifying the code at runtime. Fix that. And respond to can tell you if some class responds to a particular method. So that's an example of the code inspecting its stuff at runtime. So it can actually tell what class it is and what methods it holds at runtime. The next one was what is duck typing and how does it relate to mixins. So I said duck typing states that if a Ruby object walks like a duck and talks like a duck, then it can be treated like a duck. In other words, the type of an object and how we use it is more so determined by its capabilities than by the actual class of the object. This is where mixins come in. Mixins are a collection of methods and therefore functionality that can be added to a class so long as that class adheres to the contract of the mixin. Many different types can use these mixin methods. Let's fix that. Can use these mixin methods as long as they all implement the necessary methods required by the contract in a way that makes sense for them. So thus, different classes will all be able to respond to the same methods, acting like the same type or walking like a duck, so to speak. So a good example is the Ruby enumeral module. This allows objects to be sorted and other similar functionality. To include this module, a class just needs to implement a .each method and the double rocket shippy operator thing. So just by providing these methods, the enumerable module has been mixed in with your class, and it can now act like an enumerable object, thus quacking like one. So it's not an enumerable object, but now it acts like one.
So if I may interject, I don't know if you want to elaborate on what exactly what do you mean by contract of the mixin, because I feel like they might get you on that. Like we all know what it is, but
okay.
And I know that the contract of the mixin example is the each method and the rocket ship operator, but you might want to relate that is the contract, correct? Like that's what you mean by the contract of that example. So maybe something with the because you kind of just like gloss over what a contract is. So I don't know. Okay. I just needed to say something because you were just like talking at us.
Stale.
Okay, so maybe I'll just or at least link to the fact that is the example of the contract.
Something like that.
Okay. So then it just says like what is a mixin. So mixins are just sets of generic code that rely on certain methods being available to them. This requirement is the contract. A mixin can be, it's a separate question though, you're right.
Yeah.
A mixin can be implemented by a class by fulfilling the contract. An example would be the aforementioned .each method and that double rocket ship of the enumerable module. Once whatever methods or properties necessary for the contract are fulfilled, the mixin is implemented by the class and able to be used on instances of the class. So the next one was, do objects have type? And do the variables that reference those objects or point to those objects have type? So objects do have type, and that's statically bound. So like an instance of a class is always going to be that class or whatever like that. So an object cannot, what I said was, this is statically bound. An object cannot change its type throughout the execution of the program. Variables that point to objects do not have type. These are just names linked to the object at runtime and are thus dynamically bound. They can be unbound and reassigned to another object which may have a different type at any time during execution.
Thanks.
That's fair?
Sorry.
Okay, so difference between variables that are named with like @variable and then double @variable. So a variable with the name @var is an instance variable. It belongs to a specific instance of the class, meaning it belongs to an object and you must access it through this object. Each instance has its own variable with this name that can hold a different value for each one. A variable with the name @var is a class variable. There is only one copy of this for the entire class and is shared by all instances of the class. It therefore belongs to the class, not an instance, and it cannot be accessed through an object like object.var. Instead, it must be accessed through the class like class.var.
Heyo.
Okay, moving on. When a method is called on an object. Okay, it said what happens when you call a method on an object that doesn't have that method. So when a method is called on an object that does not have that method defined, it reroutes the call to the method missing method. If there's no method missing implementation for the class, it goes up the class hierarchy until it finds a superclass that does have an implementation of it. This is guaranteed to happen as method missing is defined in the basic object class, which all Ruby classes inherit from. So does it make sense at least that, it'll always traverse up? Thank you for the comma, Alex.
You're welcome. I was a CS301 CA, dude. You got to use those commas.
So then the next one was what's the iterator method that's used on collections in Ruby. So the .each method is an iterator available to all collection-like classes in Ruby. Here's an example of its use with an array. So r equals 1, 2, 3, 4, 5, r.each do. That's just how you implement that. Simple enough. This one was a little bit interesting. I had to look it up. It just asked like what the rules for the scope of a Ruby local variable. So hopefully this is correct. I mean, this is all factual information. I don't know necessarily that this is what she was going for, though. Ruby local variables belong to one of the following: a proc, a loop, a method, a class, a module, or the entire program. They belong to whichever of these they are most closely nested in. Where this is interesting is things like if statements or lambdas and things like .each statements. They have the same scope as whatever they are nested in, and thus have access to the local variables of what they reside in, and it has access to variables within these closures as well. For example, if you do local variables of, so if you do if true and then in brackets var equals hello, and then you say puts var exists with inside that lambda of the true block, but it will in fact be able to print var because it's defined, because that the code block of the if expression, the scope of that, since it doesn't have its own local scope, the scope of that actually is whatever the most closely nested scope is, which is what that was explaining before. Meaning that it's actually visible to whatever the surrounding thing is, which is where the put statement resides. So it'll work. Okay, then it asks what is poetry mode. So poetry mode is a way, and gives examples of it. So poetry mode is a way of making clear and neat code in Ruby by allowing you to remove unnecessary brackets and parentheses and other messy syntax on certain unambiguous method calls. Here's an example. So you can represent a.should be greater than or equal to 7. Looks nice. Is just the same thing as a.send, b.send greater than or equal 7. So it just makes it nicer. Then it asks what a closure is in Ruby and how they're implemented. So closures are first-class functions with lexical scope. This means they can be assigned to a variable, passed as a method argument, and returned as a value. They also remember the values of all the variables from the scope in which they were defined. Closures are achieved in Ruby through procs and lambdas. Here's an example. X equals 0, L equals lambda, X plus equals 1. Now if you were to pass L elsewhere and call L.call, it would return 1 and then 2 and so on. It remembers the value of its X as it is passed around and continues to increment it. So X being the value that it had when it was declared in the scope that it was originally made. Was that confusing? Did that make sense?
No, that makes sense.
Okay, cool. Then the last question was like, what is yield and how is it used? So I said yield suspends the execution of whatever method the yield is in and hands control over to some code block. When this code block is done executing, the original method resumes execution and finishes where it left off. I guess I should say and continues where it left off. So yield, sorry?
I said, yeah, that's
okay.
Better.
Yields are used for many things. They can be used to provide some code block as a parameter to a method and invoke it that way. They can also be used as generators so that a new value is only calculated in return when the method with the yield is called. So, Jackson, that was a little PL creeping in there.
Yeah, I was going to say shout out to Haskell.
Python really is where we used it most.
Yeah, Python was where, well, when we actually used yield, generators were Haskell. Yeah.
Right. Okay, so that's part A. And then I guess I'll quickly do my B as well.
Wait, what's going on with K? I'm confused on like this part where it says here's an example, A dot should be. What does it mean by, like, when you're saying be.send?
Yeah, so this is just another example of poetry mode is really just meaning syntactic sugar throughout Ruby.
Right, yeah.
So a dot should be greater than or equal to 7 is a call you can make in Ruby. So you're just saying that like the variable a should, and then b is also, so a dot should is the method call.
Right. Oh, so b is a
Method
variable.
should on a, and then b is another method, and then b takes two
Okay.
arguments.
I didn't know if you wanted to like use b or b like be. That's good.
The word b. B is also a method that takes two arguments, some kind of function and some kind of value.
Yeah, that's fine.
So it's just showing you that it's .send is the real thing that's happening in poetry mode. It's just like making it look pretty, so it looks like English versus this stupid send looking thing.
Oh, I have one more question. It's right, but I'm just wondering if you know why, just because I'm curious. In number 1, section 1, part B, part 2, where you go, did you get that? The every operation is a method call.
Yeah.
Yeah. How does it know that, like, when the number ends and when the, like, you do 1.0 point, like, 1.0.send, how does it know? Is it just because it gets a string, a character instead of a number?
I'm going to assume that's a good point. Maybe syntax. No, 1.0.send does work.
Yeah, I know it works. I just wonder if you know why.
Interesting. I would assume that has to do with the parser, right? I mean, interpreted language, so.
Word. Okay.
Okay. So,
which B did you have?
Huh? B, I had 4. So that was all RSpec questions. So this one you'll have to hold me a little more honest to guarantee that I did this right.
Yeah. I was going to say, you're pretty, as Eileen would put it, you're a Ruby guru. But yeah, so I wasn't about to correct you anyway.
So
I'm sending that video to Eileen.
4 is all RSpec stuff, so you'll have to tell me if this stuff makes sense and is like fair explanations, because there is not great on RSpec stuff. All right, so the first one, they're all just like straight up definitions, and give an example. So what's a seam? A seam is a place where you edit the behavior of your code without changing the actual code itself for testing purposes. So seams let us break dependencies between the code we are trying to test and the code that it relies on, allowing the code it relies on to behave differently in testing than it would in real life. This is used to make our test independent so that it does not rely on any other code other than exactly what we are trying to test. One example is using the should_receive method. This creates a seam by overriding the method in place to define what the return of the method should be. Does that make sense?
Hold on.
Yeah,
it's a confusing definition and rework it, but.
Is there any way you can put that example in like a code example? Because I feel like that might be hard to follow for some people.
Let's see. So like ex a dot call should
I before E except after C, bruh.
Google Docs is lacking its autocorrect game. Damn.
Okay, so like let's say it's something like that, right? So does that make it more obvious? You're just directly saying like what it should be. So you're like removing, actually having to, and you can tell me if like this doesn't explain it well enough, because the answer has to explain it, not me. But basically the idea that I'm trying to get across here is that you're explicitly saying like that's what this gives you. You're not actually getting the callback. You're saying this is what it gives you. That way you don't have to rely on it.
Seems let us break dependencies between the code and no. This is used to make our test independent so that it is not relying on any code. It doesn't really help that I still don't really know what seams are.
I'm still a wee bit confused. I get the explanation makes sense, I think.
Yeah, you probably have a lot better grasp on RSpec than the rest of us, especially now.
Yeah, but the point is that you're supposed to understand.
You're supposed to get a grasp
from my explanation, and if you don't, then it's not good enough.
It's just like that. If we could reword the second sentence, I think it would be better. And the rest
Please
is
let us break dependencies between the code we are trying to test and the code that it relies on.
Can we just
allowing
like break right
Okay,
there?
I get that that happens, but then I don't understand how exactly that happens.
Okay, so I'm gonna. This one is kind of. So this is used to make our test independent, so that it does not rely on any other code other than exactly what. That's kind of redundant. So I'm
Right.
gonna.
Yeah, making independent from and then doesn't rely on other code.
That redundant theme sentence. So I'm gonna change this sentence to like. We do this by providing what the results
Yeah, I'm gonna grab water really quick. I'll be right back.
Doubt it.
Yeah, I'm gonna do the same.
Doubt it.
that make more sense? So it breaks the dependency from the code that it relies on. So we do this by providing what the results of some method should be explicitly rather than relying on a correct implementation of a method and actually having to call it from our test.
Okay.
Okay.
Sounds like a plan.
All right, so then matchers. This one's really short because like it was hard to understand like what a matcher actually was. Matchers are built-in methods in RSpec that are used to provide expected results for comparison to the actual. Two types of, and then it just said what are two types. So two types of matchers are respond to and raise error.
Maybe elaborate on what respond to and raise error do.
It's just to give two examples, but
I don't know, but someone's going to be like, I don't know what respond to and raise error do, and then we're going to lose 2 points and we're going to be sad.
okay, so let's see. Matchers are built-in methods in RSpec that are used to provide expected results in comparison to the actual. Examples of matchers that respond to and raise error. These are used to state what.
Uh-oh. Oh. Hello? Your mic's off.
Mine?
Yeah. Yeah.
Now it's back.
You're back. Okay. Nope, now it's off again.
Oh, because I was typing. It mutes you when you type.
Oh, it doesn't.
Interesting.
Oh, okay.
Okay, so we'll go with that. And then the next one was what's an expectation and show how like they're implemented. So expectations define the expected outcomes of some expression to determine if what we are testing returns what it should. They are defined with the following format: expect actual dot to some matcher and then expected. So an example would be expect 2 plus 2 dot 2 equal 4.
Yeah, it makes sense to me. We use that recently.
Yeah. And there's also like 500 ways of saying that, which is ridiculous. But so mocks are fake instances of objects that don't really exist. They allow us to create tests that don't rely on the class implementation of the instantiation of one of its objects, keeping our tests independent. It also allows us to easily define the expected necessary data we need the object to hold for the purposes of our test. We also remove the overhead of actually creating the object. Here's an example: comment equals double comment, and then we can just do expect comment to receive, find, and return comment. We know that it returns something of type comment, so that's what it'll do. It'll work. That's a valid example, so that's really all it needs to be. But is that example explanation of what a mock is? Does that make sense? That it's a fake object?
This is of objects that allows to create tests. The double isn't a cast of double, right? That's like a mock thing.
Double is, yeah, that's how you make a mock.
I still don't get double. It's confusing as all shit.
Expect comment. What's capital comment?
It's like the class is comment.
That's the okay. Expect comment to receive. Yeah. All right.
Okay, so last one. Stubs. What's a stub? And like, give an example. So stubs are like mocks, but for methods. We can create fake implementations of some method. This fake method can be applied to both real instances of the class that responds to it, and mocks of the class. This again removes the dependency and testing of relying on the implementation of some other code for our test to work properly, as we can instead explicitly define the return value and effects of the method. For instance, allow feed.toReceive fetch and return imagine I'm a JSON string. This is then callable on both real and mock instances of feed. Will always return the string above. So, does that make sense?
Hold on a second.
Some other code for our test to work properly, as we can instead explicitly define the return value and fix.
I think like the explanations make sense from these. I'm just in my own mind having trouble, like, what am I trying to say? Productively, like seeing how I would use these. But I think all the descriptions make sense. I think it's just like a complicated topic, so there's not a much better way you can explain and exemplify how these work.
Especially without you giving like specific examples of how
Yeah,
they're.
I think the gap here is that these questions are answered in terms of like understanding TDD, and I guess like if that gap is there, then it's confusing. But that's not.
I think they make sense.
Okay, cool. So then that's it for me.
Like typical concepts.
Whoever's next.
Before we go on, I just want to say that I only have 45 minutes. Is there a chance we could pick this up in case it takes longer? Because right now, all of mine together is 9 pages, single spaced.
9 pages?
Yep. My question is hella long.
Holy fuck.
All right, so why don't we, Ben, you go next then, just to be safe. And
Would you rather do that later? Are you done or no?
I'm like done, but not. I haven't like read over to make sure anything makes sense. A lot of it's just like information patched together. I would prefer to go later if we could. Just because I don't like I said I have 45 minutes right now.
Is there another point in time before Monday that we're going to be able to do this?
We can do
And by that I mean, Lucas, what are you doing in the rest of the weekend?
Yeah, like I'm free whenever. It's up to you, Lucas, because you got to worry about graduation and shit.
Well, the thing is that my family's getting here tomorrow at like 12, but I can make like an hour to do it somewhere. Like I can.
Well, you can just skip that then if your family's here, and we'll just do the rest. Because you already have your thing in, so.
If you want, I mean, like I don't want to leave you guys to do it alone, but
Yeah, because you haven't done anything for this group.
I don't think it'll matter.
I
I'm trying to pick up the show on above and beyond. All right, so why don't we do this?
Alex, what do you got?
Sorry?
Or do you have anything done?
Yeah, I have almost all mine. I just had 2 of the letters left for my secondary question, but they're super short, and I could explain what they are. Like, I did the rest, and mine's like a total of... Mine's like 2.5 pages. It's really not that long, and it's all pretty... It's just literally like stuff that's straight from the book. Like, you guys probably know it.
Should we do this? Because it sounds like this should be the case.
Like,
We just did Lucas's. Lucas's is fine. Lucas's is ready for Monday.
Yeah.
And then, well, he'll do some stuff with it, whatever. And it doesn't sound like me, Alex, or Ben are done, really, all that much yet. And I haven't even touched question B yet. So should we just call this, okay, this is the Lucas, this was the Lucas session.
I'm honored.
And the 3 of us will do our thing, meet at a later point, and then Lucas can join us if he wants, but he doesn't have to because he's a real person.
I'm fine with that. If you guys don't mind me going, I could totally go, though. Like, when I say I have 3 of the letters left, it's probably, like, 10% of all of the stuff that I have. That everything else is done.
Okay, then, all right, we'll do Alex then.
And they're all, like, book definition
do-
ones. So
We'll
they're
do Ben and I at a later date.
okay.
Because maybe Ben can get his down to not 9 pages,
Do you...
and I can actually do
Do
B.
you have any idea how I have to go through like waterfall, V, prototype, phase incremental, phase iterative, rad, spiral, clean
Just
room,
saying, you
agile.
picked that question and made such
Oh,
a
yeah,
big
totally.
deal about picking an easy one, and like 9 pages. I can take that.
It's all easy stuff. It's just a crap load of information.
All right, Alex, let's get you started.
And I also have to put mine in like bullet form, because right now, essentially, it's just a paper on BDD with a thesis. I'm not even kidding.
All
All right,
I wrote a
I'm
paper
gonna-
on ADD.
I'm gonna just put mine in the bottom of the document really quick so you guys can see it while I talk about it.
Okay.
The bottom.
Put it like under your question, and then like
Okay. Let me find.
so I can find it. So I like can refer to the question if
So
I
the
can.
first one is gonna be A13. Let me find where the fuck that actually is.
Yeah, Lucas, I totally did this to myself.
Yeah. That's what you get.
There we go.
A13. Here we go. Yeah.
I see answer 10. Let's see. Section 2. Actually, I'll just find you. I can go to where you're looking. There we go.
How do you do that? Can you like click on his name or something?
Yeah, you can click
Wait,
on
is this B or A? This is A. You only have G parts.
I know, right?
Oh, my.
Yes.
I hunted the good questions. All right. So part A is define and explain the meaning of first. So first is a short acronym for fast, independent, repeatable, and self-checking and timely. Fast literally defines should be easy and quick to run the subset of the test cases relevant to your current coding task to avoid interfering with your train of thought, and you can utilize the Ruby tool Autotest to help with this. Independent means that no test should rely on preconditions created by other tests, so we can prioritize running only a subset of tests that cover recent code changes. Test behavior in repeatable. Test behavior should not depend on external factors such as today's date or on magic constants that will break the test if their values change. This was seen when all the 60s programs changed over into 2000 and started using multiple, whenever they use like 2 digits instead of 1. Or 4 digits instead of 2. Self-checking.
Is that in the thing? 'Cause I think you just made that up.
No, yeah. When 1960s programs, when the year 2000 arrived.
No. I meant like in your
Yeah.
actual answer, did you include that stuff about like the digits and such?
I don't know exactly what it is. They didn't elaborate on it, so I figured this would be enough, but I totally can.
Okay.
I just remember like.
I would say, Alex, the best example is like a test that relies on time or the date or something like that. You know, like a test that checks that it's Tuesday, the answer changes, right? It doesn't always give the same result.
I just remembered this because of Office Space. Right. So self-checking, each test should be able to determine on its own whether it passed or failed. You shouldn't have to rely on humans to check the output. And timely, tests need to be created or updated at the same time as code being tested. With TDD, the tests are written immediately before the code, so you don't write any code until tests are written. Then you iteratively make them pass as you continually write it.
Sounds good to me.
Yeah, that's good.
B, describe and explain what is meant by TDD, aka red-green refactor. So this just elaborates from the last question. Before you write new code, you want to write a test for one aspect of the behavior it should have. And since the code being tested doesn't exist yet, writing this test forces you to think about how you wish the code would behave and interact with its collaborators if it did exist. And this is called exercising the code you wish you had. So there are technically 5 steps a part of this process. That was step number 1. Step number 2 is the red step, where you run the test and you verify it fails because you haven't implemented any of the code yet. Step 3 is the green step, where you write the very simplest possible code you can write to make it pass without breaking anything else. And part 4 is the refactor step, where you look for opportunities to refactor the code or your tests, and changing your code structure to get rid of any unnecessary factors like redundancy, repetition, or ugliness from adding new code. And the test will ensure that refactoring doesn't reintroduce other new bugs as you continually iterate through the testing. And in the 5th step, you just continually repeat this process until the scenario steps are all complete and everything is green. Part C, what are code smells? Code smells provide qualitative but specific descriptions of problems that make code hard to read, and depending on which catalog you use, over 60 code smells have been identified. So there's a ton in the book. I went with the first 5 that I could find.
I would add just like 1 or 2 sentences to see, just to like explain in English what that actually means.
Okay.
Right.
And just to make it 1 or 2 sentences longer, honestly.
Yeah, because I feel like someone's gonna like
Just throw in stuff just to...
be like lick their chops when they see the answer that's only 2 lines.
Word, yeah. The book didn't really. The thing was, too, is like it didn't really say much about it, but I'll look it up online.
Well, like just your interpretation of it after that. You know, just
Right.
what this means.
Like something's wrong.
I think.
So part D, list 5 code smells, discuss their symptoms, and explain what can be done to refactor. First code smell is composing, which is made up of the extract method, and a refactoring could be to replace a temp with a method or to introduce an explaining video. What the hell?
What in the world did you just say?
Alex.
Explaining variable was what that's supposed to say. I was like, that can't be right.
Extract method? What does that mean?
Yeah, I don't know. I have to go through and like add to these. This was the one I was working on as we.
That's my one. Yeah, my one feedback on this is just like explaining
Everything.
on all of them, like why whatever it does fixes it.
Right there.
Yeah.
So I could just make a chart for this and like lay it all out in a 5x5
Ooh.
grid.
Oh, that would be
Technical on
so
that
good.
shit. All right.
That would be the greatest eye candy of all time.
Yeah. All right, so let's move
Plus,
past.
never will be able to touch
Like,
it.
definitely, all the information is correct. It's just like
Yeah, this one is the one I was working on, so we'll just skip this for now. There's just those 3 left after this, so they're like fairly simple. I'm sure I can handle it, and if not, I'll call for help. Let me paste in. The next one I had was B11, and there's only A and B to it. Super easy.
Oh, you wanna hear something funny?
No.
Do you know what?
I didn't understand the question.
Did you hear that voice just now?
Who is it?
Yes.
Okay. Do you know what an Amazon Echo is?
Yeah.
Oh God.
Okay. So the wake word for it is it's gonna do it. The wake word for it is Alexa. That's how you activate it. Stop. And your name is Alex. So I guess I said the word Alex and within a close enough space that it thought I said its name, so it turned on.
Silly Amazon.
Anyway, let's continue. Alex, go ahead.
Whoever did that? Right on with the SpongeBob references.
References on point.
Do
If
you ever
you
have the Hey Siri problem where you just like turns on and starts listening? That happens all the time.
No, because I don't often say, "Hey."
every day.
I don't say it either, but she just picks it up.
Doing the OK Google thing for the Android, my particular phone, it's so annoying because you don't even have to say OK Google. You could just say like and it'll just like go off anyway. I'm like, all right, I'm turning this off. Anyway, where are we at? B what?
How'd it go? One second.
So from the next week they have their Christmas break starting. So
Oh my God, Alex.
like, they're not gonna hire anytime soon till the 5th.
Oh, he's in his office.
Well, that's good.
He's like, I'll call you again after the 5th.
Oh, okay. Good shit.
So
Awesome.
the sad part is I'm leaving for India on the 6th,
But you'll be back.
9th of Feb, and I don't know when the industry is going to start.
I'm sure you can work something out. You'll be good.
Yeah, that's all set.
Glad to hear, man. All right. So the next one I had was B11. I just pasted that in the document. I don't know why that's referencing itself as B. That's supposed to be. This is supposed to be A. So part A is to
So,
define
It
and
has
describe
2
each of
parts.
the. Part A is define each of the solid principles.
honestly, I'll just be like, it's good because.
Oh, can I just talk, or are we just gonna cut me off every time?
Straight out of the textbook. Get these questions.
Yeah, so I mean, if you guys want to read it real quick, they're straight from the book. So
I have one and only
I
one.
strategically picked this shit. You know,
Must be open. Watch your mouth. This is
trying
live.
to do real work. I mean, this stuff.
What are the chances that she watches every single video?
Dude, I could guarantee, and I quote, not a single video that we've uploaded will be watched.
We could like
I
put it
could have
like
been running around with my shirt off.
All right, Alex.
Whatever.
Same thing as before. My only thing would be if you want, just because she'll be like, oh, okay, what does that mean? Like adding one sentence to each that just explains what that means in English, right? Like,
Okay. Yeah, like my own interpretation.
For
Like,
part
I don't
A,
think
you
that's
kind
like
of
all-
only.
but
Yeah.
the reader principle: speak only to your friends, treat your friends as strangers. Like, treat your friends as strangers, like it's a cute little sentence, but like what does that actually mean in terms of the code? You know what I mean?
Okay.
Yeah, and you kind of just So basically, what he's saying is you
Explain what they really
defined them. You defined them, but you didn't describe them.
Provide some details. Okay.
Right.
Explain. Yeah.
Other than that, looks good.
The second part, though, is pretty straightforward with, like, what is it, what are the warning smells, and then how would you refactor it. I think those ones are pretty set.
Yeah.
And there's things like I don't know what a refused bequest is, unless that's it's supposed to be request.
The one thing you could
No,
say
it's
is like
refused
how it
request.
fixes it, but
What does that mean?
In which part? Right here.
Refused bequests.
It was like, see, that's the thing I'm wondering is, like, a lot of this stuff here is, like, definitions that we had in the book
Okay, so
that we're
the only-
expected
the
to
only
know,
thing-
so should I bother explaining them or no?
the only thing you can do to fix those, and I'll just like leave it to you to decide if this is worth it or not. What I would say is, for example, and this isn't like work for all of them, if something is like a code smell where you have repetitive behavior constantly done over and over, and you know the textbook says that one of the ways to fix this is the strategy pattern, right? Don't just be like, oh, repetitive behavior is fixed by using the strategy pattern. Then add one more sentence that's like, this is because the strategy pattern wraps consistently done steps into one defined structure and then allows two different classes to implement those rules differently, and then they're able to reuse the same structure. So just like explain why it helps it. That's it.
That'll make sense. Yeah, I didn't know, like, if it...
But literally, it'll take you an extra sentence to 2 per one.
Yeah, that's totally fine. I just didn't know if it was worth explaining, like, the terms that are in the book and whether or not she wants,
No.
like, as if we're explaining to someone who has no idea what the hell we're talking
I
about.
think
So,
you're fine.
yeah, those were my 2.
All right.
So, yeah.
So we will regroup sometime over the weekend.
Do you guys have a good day or time that works for you, or?
Honestly, Sunday's my best day, but I can potentially do tomorrow between like.
If it's not Saturday night, I don't care because I'm trying to watch the Jet game.
All right, yeah, I'm fine with whatever as long as you guys don't make me get up at like 8 a.m. Then I'll murder you all.
I mean, I'm not gonna be up at 8 a.m. So.
All right.
Are you gonna work tomorrow, Ben?
Well, tomorrow I'm definitely sleeping until like noon, but Sunday we'll see.
Can't work during the
All
day.
right, so it's probably Sunday from what I'm gathering.
Word. All right, sounds
Word.
good to me.
All right.
Is there anything
Ben,
else
you
we
got
have to worry
this
about?
recording under control?
Yeah, I don't know what to do about that. So,
I assume Ben has that under control.
Ben, are you
This-
good on the
this
recording?
Yo,
Is that-
this recording? Yeah, I got this down.
Okay.
So we just upload this link to the doc, and then or a pivotal checker rather. Is there anything else we have to worry about taking care of individually before Monday?
For the
Like
project,
anything
you mean?
project-wise or final-wise or like other shit?
I have a couple things that I was going to go through, and I will let you guys know if there's anything that needs to be done. It depends on her responses to my email, so once she
Okay.
you guys know.
And you
We never
just set
fixed
up the time, right?
I asked her. That's part of what I'm waiting on.
Okay.
We never fixed Project 4, right?
I may have fixed it, but I've been trying to upload it every day, and the autograder is still broken. Last word I heard from her was an email maybe like 5 days ago that said she contacted Sam, who's one of the edX guys, to fix it, but I don't know when it will be fixed. There's an error in the autograder right now in the actual process that's in the browser, so
Gotcha.
I have no idea. But if it's fixed and it works, I'll just send you guys a zip. It should be 100 because I'm pretty sure it's fixed. So
Cool.
Okay.
All right.
There you go.
See you guys later.
all right,
Just
gentlemen.
don't fall off
Have a
the
good night.
stage tomorrow.
Oh, also, Austin's
Sunday,
doing his
but I
thing
won't.
tonight, so go to that.
What?
Austin Thompson is doing his thing tonight.
Was that the thing on Fly Leroy?
Yeah.